Welcome. This is Math 313, Linear Algebra. So, my name is Mel Nathanson, and this is a summer school class, so it's going to be very intense. We have 4 weeks to cover a huge amount of material. That is the amount of material that's usually covered in 4 months. So, every week is like a month, and every day is like a week in terms of work. So, you really have to expect to put a lot of time in for this class. We cover linear algebra, and this means in mathematics what are called vector spaces. Vector spaces and the functions between them, linear transformations. So for many of you, this is the first 300 level math class you've taken, the first class beyond calculus. And it's going to be quite a bit different because once you get beyond the sort of the routine classes in math, like calculus, um, you come up to the core of mathematics, which is trying to understand abstract concepts and prove things. So in this course, for many of you, this is the first time you will have to learn how to give a mathematical proof, and this takes a lot of time. It's not easy. So roughly half of the course, half of the exams will be computational problems. So these are things you're familiar with from calculus. But half will also be proving not very complicated things, fairly elementary things. But if you've never given a rigorous mathematical proof, it takes a lot of time to understand. We start off studying something very concrete, linear equations. So in high school, you learn things like solving two equations and two unknowns. And we study more generally any finite number of equations and any finite number of variables. So you could have 10 equations and 8 variables, and you want to find all the solutions, or you want to find a solution, or maybe you can prove there is no solution. But linear equations, that's the starting point. That's very concrete. But we see that in order to solve linear equations very quickly, you have to introduce the concept of a vector space, which can be very concrete or abstract. It's sort of a rough rule that things are abstract until you understand them, and then they become concrete. And most of the course is the study of vector spaces and the functions between them. Functions between them are what are called linear transformations. We'll learn that vector spaces have something called the dimension. So you think of a one-dimensional space as just a straight line. And a two-dimensional space is like a plane. Three-dimensional space is the space we seem to live in. But there's no restriction, no reason to restrict ourselves to 1, 2, or 3 dimensions. You can have 4 dimensions, 5 dimensions, 800 trillion dimensions. And you'll learn how to prove theorems about vector spaces that have arbitrarily high dimension, even sometimes infinite dimensions. And again, this is a completely new psychological approach to mathematics if you're not used to abstraction and proofs. And the more time you spend trying to understand the basic concepts, the better. It's really hard to learn this in the beginning. So that's what our course is about. The main textbook are lecture notes that I prepare and I've posted or will be posting almost every day on Blackboard. I do recommend, or not recommend, I do list a few textbooks in linear algebra that are excellent sources to help you understand things you might not understand. I try to pick books that on the one hand are extremely good and on the other hand are very inexpensive. So one of my favorites is this Dover paperback by I.M. Gelfand, a great Soviet mathematician, called Lectures on Linear Algebra. Costs, I don't know, maybe $9 from Dover, and you can always get it from Amazon. But the main text is my lecture notes, and they're written out and they look like a book. They're produced, and they include not just the theoretical content and many examples, but all the homework problems come from the notes. We'll have 3 short exams in the course of this 4-week summer school term. one at the end of each of the first 3 weeks, and then a final exam. And your grade is based on your homeworks and your exams and your final. And that's it. I mean, that's very sort of cut and dry. It's very simple. I am available at fixed times on Zoom, but if you need to talk to me or if you have a question about something mathematical, you can also send me an email and we can just arrange a time one-on-one for us to talk. Welcome to linear algebra.